Video response to the logic-only zone. So Mr. Zone posted a video response to me, and I think things are moving along. We've established some nice adversarial roles. And so, on a side note, he asked me if I'm glad he has friends. I am. I'm glad you brought him into the conversation. As you point out, they might have a role to play if it happens. I don't know. More importantly, it seems that Zone and I are beginning to start communicating on this. We've kind of established some adversarial roles and laying some stuff out on the table about what we think. So that's cool. And indeed, Zone's video allowed me to find, I think, what's a source of the disagreement. I did some research on the book he uses called Logic and Contemporary Rhetoric. And what I found was a Wikipedia article that talks about this book. Now, this Wikipedia article is called Informal Logic. And informal logic is what this book teaches. And so, informal logic, it's kind of an oxymoron, right? It's like saying military intelligence. The whole deal with logic is that it's a set of rules, formalized rules for reasoning. So I think this book may be a source of the fallacies I'm getting from Zone often. And some examples are from the video they just did to me, are some contradictions. He says, I don't have an agenda. I want people to use logic. When wanting logic was the specific agenda I was pointing out that he uses. He also responded to my assertions that logic was an archaic form of reasoning by saying reasoning has been around for a long time. Now, first of all, being around for a long time is kind of a prerequisite for being archaic. And then secondly, more to the point of disagreement, logic is not the same thing as reasoning. Logic is a form of reasoning, but not all reasoning is logic. For example, in addition to logic, there's math, and there's science, and there's guess and check methods of reasoning, communication, statistics, theology, critical thinking, and now this informal logic system of reasoning. So he asked me to prove my assertion that logic is an archaic form of reasoning if I want him to respond to the rest of my video, which I don't. That's not my goal, is to get a response so much as responses might be a necessary part of the process. But what I want is that, just to point out that Zone needs to abide by his own rules. If he's going to say logic only, we'll do some logic. So he wants me to make a he wants me to prove that my assertion that logic is an archaic form of reasoning. And to do such a proof would be self-referential. You can't use logic to evaluate logic. It'll wind up in some paradox. So I'm going to do a video where we're going to do logic. It's going to take me a couple days to put together, and it's going to go through some stuff. It's going to be sentential logic, predicate logic, modal logic, how it works and how it doesn't work. You can be patient on that. Another thing I can't do is I can't specifically say why informal logic doesn't work, because I don't have direct access to the same book. But what I'm going to do today in this video is do a demonstration where I show something similar about critical thinking, and the Wikipedia article noted that informal logic is very similar to critical thinking, and as such it belongs in a communications class about argumentation and not in a philosophy class. I hope that this will suffice until I put together my video on actual logic. It goes into some detail here. And so, as it turns out, my friend Kenneth Katona has also put together a video response to me at the same time that Zone, or he responded to the same video that Zone responded to. And in response to it, he makes this video where he goes on the internet and he reads off a bunch of rules for critical thinking. He doesn't say why he does that, but as it turns out, it kind of is handy. He does have something interesting he says in the comment section. He talks about, look, when I'm making a video, I'm not usually doing something formal. I'm just stating an opinion. I'm just expressing my feelings. And so this is why I hold Kenneth to a different standard than Logic Only Zone, because they're doing different things. With Kenneth, I'm like, hey, man, let's make it clear. I think your philosophy is good. I think, but it's hard to understand you, so it's hard to know if your philosophy is good or not, and so I'm trying to work on more on communication, so then we can, maybe talk about ideas more. And then with Zone, I've said it, if he's going to advocate for logic, we're going to, the rules, I don't know, let's get started with the demonstration and go from there. That about goodness. Okay. So what I'm going to do here is show that using the rules of critical thinking do not guarantee truth, and that breaking these rules, committing fallacies to these rules, does not guarantee being wrong. The only thing that following the rules a given system of reasoning guarantees is that you followed the rules. However, using rules correctly does make an argument more badass. If you can follow the rules of a system of reasoning, or even better, seamlessly move between systems of reasoning and use mixed strategies, it makes your assertions harder to refute. To use a metaphor, being a badass of reason builds a fortress of soundness and validity around your statements. Now the example I'm going to use in this demonstration is arguments concerning the statement, "The sky is blue," and so we begin.
Okay, you might want to make your screen bigger here. Some basic tips on how to evaluate arguments. Characterize the argument being made appropriately. The type of argument, level of argument, nature and form of argument, scope of argument. Make sure that all that follows is in line with this characterization.
Okay, so this first one's about types. There's many types of reasoning: logic, common sense, intuition, named some of these kind of things before. Deduction versus induction, that's an important one. Universal claims versus general claims versus specific claims. Falsifiable claims versus economics. Math. Is the argument a claim on solid truth, general truth, subjective truth, this kind of stuff. And none of these types of reasonings are always correct or always incorrect. Some systems of reasoning will show different truth values for the same statement. Now, to really get into this, we'll have to have more than one system of reasoning. Right now, we're just doing critical thinking. So next week, or later in this week, when I get this video put together, then we'll have multiple systems of reasoning when we talk about logic. So we'll get into that a lot more in that video. But one system of reasoning might come to the right answer for wrong reasons, right? I can do math calculations to show the sky is blue, but use the wrong math, right? So if I use revealed preference theory to talk about why the sky is blue, then the answer I'm going to get is that the sky is blue because we want it to be blue. Even though revealed preference theory is a valid form of math, it would be the right answer for the wrong reasons. However, being adept at different types of reasoning will make your arguments more badass. But again, we'll do more than one system reason to show this. So when I get in the video later this week, that's when it's all going to come clear.
Ask yourself clearly, what am I being asked to accept? What are the claims, argument being made? And then,
so again, it's being clear is important for communication, but clearness does not guarantee truth, and neither does being unclear guarantee wrongness. For example, if I say the sky is cerulean, then less people are certainly going to understand what I'm saying than if I say the sky is blue. But so while it's unclear, it still has the same truth value as the sky is blue. I can say the sky is blue, and while this idea is a simple idea, it'll still be wrong at night. So understandability doesn't necessarily imply truth, and being esoteric doesn't necessarily imply wrongness. But then again, being understandable is somewhat badass. You know, I can't expect people to agree with my assertions if they don't understand me.
identify the premises on which the argument is based. What assumptions do these make? Are these valid?
So, premises don't make assumptions. Premises are assumptions. Premises are not valid or invalid. Arguments are valid or invalid. There's a specific rule about validity later in this video. And again, validity will be talked about a lot, of course, when we do the logic video. But this is about premises. And premises in an argument need to be taken as given and assumed true. Now, they're also going to be need to be questioned the truthfulness of, but that's about soundness, and soundness is a different thing. But for validity, you need to just assume that the arguments, that the premises are true. So like, okay, so if I say sky's blue because there are interactions between the light and water particles in the sky, then I would need to relate that the blueness of sky would result from the existence of light and its interaction with the presence of water molecules. But I don't need to prove there that light exists. Now, if someone calls you out on it, then you might, right? If someone says, well, the air doesn't feel wet, how do I know there's water particles in there? Then you might need to prove that there are water particles in the sky, but that will be done not in the argument, that'll be done in a separate argument.
Make sure you fully understand the argument in the manner in which it is being proposed. If not, seek out further information until your grasp is sufficient to evaluate the claim.
So, making an argument understandable is important if we want others to understand the argument. Communication is the difference between what the sender of a message is sent, or what he meant, and what the receiver of a message understood. Language is a tool to express ideas, an abstraction of truth. I can't have truth come out of my mouth. I can only have an abstraction of truth come out of my mouth. Language has its own limitations. While we cannot explain everything in a single argument, we do want to make sure that we do what we can to avoid misunderstandings. Ciolas azules. Needless to say, people will not think you are a badass of reason if they can't understand you. Hence, if you learn a second language, you increase your badassness.
Identify both the claimed and the unclaimed logically links between the premises. Are these sound and supported? Do these make sense and logically follow? Ask yourself, what are the logical consequences of the premises, and are these fulfilled in the argument being presented?
So this has two parts. He talks about soundness, which is what the thing is that asks the question of, well, are these premises correct? Do we need another proof? And logically follow is about validity. Now, soundness is the kind of thing where we question the truthiness of the premises, like, does light exist, right? So we say, hey, well, you claim about the sky and blueness and light and water particles. How do I even know that light exists? Because if the light didn't exist, then the sky couldn't be blue now, right? So how do we know light exists? Well, quantum physics. Well, how do you know quantum physics? Well, I don't really know quantum physics, but there's these bunch of scientists that they've done these spooky experiments with light. Well, how do you know light exists? Soundness can be tough, right? There's infinite regressions, there's circular regressions. Circular argument is necessary if what you're trying to explain is a positive feedback loop or a negative feedback loop. Either way, you need a circular argument. And that's something that logic doesn't do. So, and with validity, this is about, does the conclusion logically follow from the premises under the assumption that the premises are true? And so what this is saying is, does the argument structure follow the rules of logic? Again, that's the next video where we do the sentential, predicate, and modal logic, or at least bits of modal logic. And we'll see that some statements have different truth values dependent on which set of rules you follow. And how creating a system of rules to fix problems results in more problems. But for right now, I want you to consider the idea that being invalid does not mean that you are wrong. Consider this example. The sky is blue, therefore we should go to the park. Now, it could be that, we could also go to the beach. But does that really mean that going to the park is wrong? How many of the ideas do we need to consider? It's like, well, the sky is blue, it's a beautiful day out, let's bang our heads against the wall. Like, we don't even need to think about that. Regardless, the argument won't be valid until we do. So, going to the park sounds like it can be a pretty good idea. Maybe it's better than the beach, maybe it's not going to the beach, but just because the argument is invalid doesn't mean that we'd be wrong to go to the park. So this pattern of the video should be clear by now. I'm going to say next, while soundness and validity do not guarantee truth, using a good degree of soundness and validity in your arguments is way more full of way more badassery than random nonsense backed up by woo. There you go.
Identify and examine any predictions that follow from the argument, both the predictions made explicit within the argument and others you have independently spotted. Are these supported?
This is about predictions. Now, predictions happen in the future, hence their ultimate support will be in the future, somewhere outside of the argument. Now, predictions are pretty badass because they indicate falsifiable claims, which then can be kind of tested. But they're not good reasoning in and of themselves. I can say the sky will be blue tomorrow, and just because it happens that way, if it does, well, I'm no weatherman, I was just lucky, right? I can also make a wrong prediction, but have it be a prediction that's based on good reasoning. Now, sort of. Any attempt to predict the future is likely to succumb to some problems regarding the problem of induction, that we cannot necessarily say that tomorrow will be like today. Right, if the sky's blue today, the sky may not be blue tomorrow. That's certainly a case where we wouldn't want to use induction. Math can often get away with induction, but the The future is pretty hard to predict, but if I could predict the future, that would be badass. And some generalizations about the future are likely to be right, and that's pretty badass too.
Identify any ambiguity in the argument that demonstrates its limitations.
So what he's talking about here is contradictions, and specifically contradictions with ambiguity. There's some things about contradictions. We live in a world where some things are contradictory and ambiguous. Now, when I say this, people always want examples, so there's some. Printing money both increases and decreases inflation. Quantum particles are both point-like and wave-like at the same time. The set of all sets that do not have themselves as an element. People wanting to be objective when objectivity requires the non-usage of motion and therefore cannot be wanted. Furthermore, when we look at what might look like a contradiction in an argument, may just be hidden lemmas, like missing statements that create the ambiguity, right? So if I say the sky was blue, and then say the sky was gray, this might not be false. I just didn't mention the part where the storm clouds rolled in. Now, in my opinion, I might have to go into this more, but to be a badass, right, because there are contradictions that exist in the world, you must be able to explain both the existence of contradictions and the existence of consistencies, because they both happen. And that's why one of the reasons that logic is an archaic system of reasoning, because it doesn't, when it receives a contradiction, it just says false.
Identify necessary and sufficient conditions and links between claims and statements within the argument.
Okay, so this is about definitions. And in my last video to Logical on Its Own, we're talking about definitions are important. Now, a necessity is, when it's a necessary is a minimal definition. And sufficiency is a maximal definition. The sky is not orange is necessary for it to be blue, but it's not sufficient to be blue because not orange could be purple. To say the sky has a color wavelength of 463.2 is sufficient to be blue, but not necessarily, because 461.7.3 is also blue. Right, so necessary definitions are overkill, sufficient conditions are an under-description, and a proper definition would be a set of conditions such they are both simultaneously necessary and sufficient. Now some sets are easy to find, like the set of even numbers, while some are more impossible, like the set of what is sky. Is the air in your house sky? Is the atmosphere on Mars sky? Where do we draw the line between sky and cave? And to get the exact right amount of sky. Not easy. And even if you did.
Think about the methods used to generate the evidence. Are these methods valid, reliable? Can they support the claim? Consider.
So this is about evidence, and that's a whole world unto itself. It's not a great answer to this. Evidence is shaky. Now examples are concrete, but they only refer to specific cases, and you would need to be able to generalize this to these assumptions, which we'll next video. Because the generalization of a specific case requires some evidence as well. Statistics refer to general cases. but are not concrete. There's like so much subjectivity in data analysis, as mentioned in the last logic only zone, which I was not allowed to go to, but that makes sense. I mean, there's this adversary thing, right? So it makes sense. On the other hand, one can have a lot of evidence and still be wrong, right? Now, we used to think that the sun went around the sky, causing it to be blue. And it wasn't just because it looked that way. The math they used to predict the seasons disproved the idea that the sky and the earth circled the sun. There's a lot more to go into that about circles, right? If you say, well, no, the earth circles the sun, you're wrong. The earth ellipses the sun. And so in order to make a claim without actually going out into space, which people couldn't do back then, to make a claim about the earth going around the sun, then you would need to explain why it's ellipses and not circles. And that, was Newton, but that took a long-ass time. To be able, back then, in order to be able to predict crops, they needed to use a circular system where the sun went around the earth. So that was a long time ago. There's more modern examples for sure. The evidence thing is tricky. I think data analysis is a wonderful thing to learn. Learning about data analysis. Now you're getting some badassness on a professional scale. Anyways, I hope you enjoyed my video. I'm sorry don't have that same flair that Logic Only Zone has. I know I'm pretty boring, but I don't think I am wasting your time. I think when this is all done, you're going to be a much better reasoner than present. At least that's my prediction, but my prediction is absolutely based on cognitive bias. All right, I'll see you in a couple days when I get this logic thing put together, and it's going to be worth the wait. This one's the one to watch, this thing coming up that I keep promoting. Boom.